NEET 2018 question from thermal properties of matter. The problem is like this. The power radiated by a black body is P and it radiates maximum at a wavelength lambda naught. If the temperature of the black body is now changed, it radiates a maximum wavelength of 3 by 4th of wavelength. Then what is the new power radiated? If it is n times, what's the value of n? So the first thing that we need to use is, as wavelength is changed with respect to temperature, as per a law called Wien's displacement law, lambda m is inversely proportional to absolute temperature of the body, or lambda m1 by lambda m2 is T2 by T1. If lambda 1 is lambda naught, lambda 2 is given as 3 by 4th of lambda naught equal to T2 by T1. Lambda naught will cancel. 4 by 3 equal to T2 by T1 implies T2 equal to 4T1 by 3. That's the first understanding that we need to get. Then the next thing is, we need to know about power. As per there is another law called something like Stephen's law. As for Stephen's law, energy emitted by a body per unit surface area per unit time is directly proportional to 4th power of absolute temperature. So energy by time is directly proportional to area into temperature power of the 4. Energy by time is called power, directly proportional to area into temperature power of the 4. As area is constant in both the cases, power is directly proportional to 4th power of absolute temperature. Then P2 by P1 equal to directly proportional to T2 by T1 whole power of 4. T2 we got it as 4T1 by 3 by T1 whole power of 4. 4 by 3 power of 4, that is 256 by 81. He said P2 by P1 is n times of that P1. So what's the value of the n he is asking? So n is obviously 256 by 81. That's how we solve this problem. So while solving this problem, we have used it through two laws, Wien's displacement law and Stephen's law. Wien's displacement law says lambda m is inversely proportional to T. Stephen's law says energy per unit time is directly proportional to 4th power of absolute temperature. Knowing both these things, we can quite easily solve the problem. That's it. And thank you for watching.